Alright guys, so we're going to be talking about chapter 8 for the next couple of weeks, and that's chemical properties and changes. So we've looked at atoms, how they combine into molecules and compounds, and then how that transitions into different states of matter. And then we just finished talking about the periodic table, so now we're going to go into how that combines into chemical reactions. And that's the whole of chapter 8. So today we're just going to talk chemical properties and chemical changes. So a chemical property is the ability or inability of a substance to combine with or change into one or more new substances. So before we have physical properties, were basically things that you could observe about a substance or an object without changing that substance or object. But chemical property, when you look at or observe a chemical property, it changes the substance or the object, for example. And these examples right here, these are what you're going to write in the box next to the definition. So for example, flammability, that means it has the ability to burn. And if you burn a piece of paper, it's now irrevocably changed. That piece of paper will no longer be a piece of paper. Ash and some gas. Um, Oxidation, decomposition, composition, pH, all these things are examples of chemical property. Another one that you would think of would be like oxidation is another example of rusting. So a car rusting, that's or the ability to rust. Those are all chemical properties. Then you have chemical change, and chemical change is a change of one or more substances into another substance. So chemical change basically means that you're going to take a substance and change it into something else that is no longer the same substance. With physical change, it was something like, let's say, changing from a solid to a liquid, going from ice to water. The water is still water, whether it's liquid or solid. In a chemical change, you physically have differences. So you've got a substance changing into something else that is no longer the same as the original substance. And here for your pictures, I just want you to draw 2 or 3 of these that you see here with the explanation. So here you've got a chemical change. It creates a new substance that's different from the original one. So it has properties different than the starting materials, and you can't get them to go back easily. So physical changes can be easily reversed, but chemical changes cannot be easily reversed. So you've got, when you cook a raw egg, you can't make this cooked egg back into a raw egg. When you mix cake together and then put it in the oven and cook it, reactions happen. You can't get this cake to go back to cake batter, and etc. And this gives you some examples of what physical changes are, so you can see the difference between the two. And then dissolving is, we kind of all know what that is. It's a process where you have substances mix evenly with one another. So you have one substance dissolved into another and they mix evenly. Okay, in that box at the bottom, we're going to talk about chemical equations and balancing. We're going to go over this more in class. And I will tell you when to write. Right now you're not writing, you're just listening. So subscripts and coefficients are things we've talked about before. We know that the subscripts are the little numbers off to the right. Right here, this would be a subscript. Okay, after the element symbol, and it tells you how many atoms of this element there are in molecule. So for example, here you have 2 oxygens, okay, because the subscript 2 is attached to the O. A coefficient, on the other hand, is a large number in front of a whole molecule. So the whole molecule is a CO2, and the coefficient in front is 2. And that multiplies everything that comes after it. So in this entire molecule, we have to multiply this 2 by the subscript for C, which there isn't one, which means 1. So 2 times the subscript 1 is 2 carbons. And then we have 2, the coefficient, times the subscript of O, which is 2, which gives us 4 total oxygens. So by multiplying this coefficient by the subscripts for the molecule, we find the total number of atoms of each one of each. So again, we have 2 times a subscript of 1 for C is 2 carbons, and 2 times a subscript of 2 for O is 4 oxygens. Reactants and products. So the reactants are the starting materials and products are the ending materials. So reactants are the things usually on the left side, and they're the things being added together. And the products are the ending materials or the things that you get after the reaction is done. Okay, so chemical equation balancing. What you're going to do is you're going to take underneath each side of the equation, you're going to write down the number of molecules on each side. So you're going to say, I have what elements? I have C and I have O. So C and O, I write those under here, and then I count the subscripts and I write them down on this side, on the left. Then I go over to the product side. I write down the elements I see there, C and O, and I write down how many atoms of that element I see. For C, there's 1, and for O, there's 2. If the number of atoms on each of these sides match, that means it is balanced. So in this case, okay, you have 1 and 1 and those match, and 1 and 2 do not match. So this chemical equation would be considered not balanced. Then we're coming to parentheses. So you have to multiply the subscript outside by everything inside the parentheses. So in this case, if we write down the elements we see, we have Ca, we have O, which is here, and we have H, which is here. Now we have to look at the subscripts and see how many of each we have. So for calcium, we have 1, because it's not inside a parentheses, there's just 1. If you have a parentheses, you take the subscript outside the parentheses, and then you multiply it by what's inside. So there's 1 O here, times 2 is 2 O's, and you have 1 H here, times outside subscript is 2. Down here we have a coefficient of 2 and a subscript of parentheses of 2. So we write down again what we see, Ca, O, and H. So we have Ca, O, and H. And we do the parentheses. So we have 2 O's and 2 H's inside the parentheses, but then we have to take this big 2 and multiply them through here again. So 2 O's inside, 2 H's inside, times 2 is 4, and times 2 is 4. So it gives us 4 O's, 4 H's, and then the big 2 times the little Ca is 2. Okay, so now what I want you to do is write this down. Okay, the Ca plus H2O, Ca parentheses OH2 plus H2, and I want you to find how many of each there are, how many atoms of each. So how many Ca's do I have here? How many H's do I have here? How many O's are here? And here on this side, how many Ca's here? O's here, and H's here. And you're going to tell me, is it balanced or not? Do these sides match? And we'll go over more of that in detail in class. I'll see you guys then.